Imagine a world where color bursts into sound. Picture yourself walking through a field of flowers, each bloom not only dazzling your eyes with its vibrant hues, but also serenading your ears with a unique melody. The red roses might play a deep, resonant drum beat, while the yellow daisies could sing a cheerful tune on a xylophone. This is a world where every color has a corresponding sound, creating a symphony of sight and sound that is both mesmerizing and enchanting. Red might be a deep drum beat echoing through the air with a powerful rhythm that you can feel in your chest. Imagine the intensity of a sunset, its fiery reds and oranges translating into a crescendo of drums, each beat resonating with the warmth and passion of the colors in the sky. Blue could be a gentle flute, its soft, soothing notes drifting like a cool breeze on a summer day. Picture the calmness of a clear blue sky, its vast expanse filled with the delicate, airy sounds of a flute, bringing a sense of peace and tranquility to your mind. This is not fantasy, but a question scientists ask: can we hear colors? Researchers are delving into the mysteries of the brain, exploring how our senses of sight and sound might be more interconnected than we ever imagined. They are investigating whether it is possible to translate visual information into auditory signals, allowing us to experience colors in a whole new way. Our senses, like sight and sound, are separate in our brains. Each sense has its own dedicated area, processing information independently. However, there are intriguing overlaps and connections that suggest a more complex relationship between these senses. But what if there was a way to bridge them? What if we could create a device or develop a technique that allows us to hear the colors we see? This could revolutionize the way we perceive the world, adding a new dimension to our sensory experiences. To translate light waves into sound waves, scientists are working on innovative technologies that could make this possible. By converting the frequency of light waves into corresponding sound waves, we could potentially hear the colors around us, creating a multi-sensory experience that is both fascinating and immersive. This essay explores the fascinating possibility of hearing colors. We will delve into the science behind this concept, examining the research and experiments that are paving the way for this groundbreaking sensory integration. We will journey into the world of synesthesia, a condition where people naturally experience a blending of senses. For some, hearing a sound might evoke the perception of a specific color, or seeing a color might trigger a particular taste or smell. This phenomenon provides a glimpse into the potential for our senses to be more interconnected than we typically realize. Delve into the science of the brain, exploring how neural pathways and brain activity contribute to our sensory experiences. We will look at how the brain processes and integrates information from different senses and what this means for the possibility of hearing colors. And imagine the impact of this new sense on our lives. How would our daily experiences change if we could hear the colors around us? From art and music to communication and technology, the ability to hear colors could open up new avenues for creativity and innovation, enriching our lives in ways we have yet to fully comprehend. Synesthesia is a real condition where senses get mixed up. People with synesthesia might taste sounds or see letters in specific colors. For example, a synesthete might experience the name John as always being red, no matter what color it's written in, or they might hear a violin and see swirling shades of gold. Synesthesia shows us that the brain is capable of unusual connections. It suggests that hearing colors might not be as far-fetched as it seems. Sound and light are different. Sound is a mechanical wave that requires a medium like air, water, or solids to travel through. It moves by vibrating the particles in these mediums, creating a wave of pressure that our ears can detect. Light, on the other hand, is an electromagnetic wave. It doesn't need a medium to travel and can move through the vacuum of space. This fundamental difference is what makes the idea of hearing colors so fascinating and complex. Sound travels as vibrations in the air, creating waves that our ears can pick up. These vibrations cause the eardrum to move, which then sends signals through the tiny bones in the middle ear to the cochlea. The cochlea is filled with fluid and lined with tiny hair cells that move in response to the vibrations, converting them into electrical signals that the brain can understand. While light is made of electromagnetic waves, which are part of a spectrum that includes not just visible light, but also radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. Each type of electromagnetic wave has a different wavelength and frequency, which determines its properties and how we perceive it. Visible light is just a small part of this spectrum, and it's what our eyes are designed to detect. Our ears pick up sound vibrations, converting them into electrical signals that travel to the brain. The brain then interprets these signals as different sounds, allowing us to hear everything from a whisper to a symphony. This process is incredibly complex and involves multiple parts of the ear and brain working together seamlessly, and our eyes detect light. When light enters the eye, it passes through the cornea and lens, which focus it onto the retina at the back of the eye. The retina is lined with photoreceptor cells called rods and cones. Rods are sensitive to low light levels and help us see in the dark, while cones are responsible for detecting color and fine detail. These photoreceptors convert light into electrical signals that are sent to the brain via the optic nerve. These signals then travel to different parts of the brain for processing. The auditory signals go to the auditory cortex, while visual signals are processed in the visual cortex. Each of these areas of the brain is specialized for interpreting the specific type of information it receives, allowing us to experience the world through multiple senses simultaneously. To hear colors, we would need to change how the brain interprets sensory information. This would involve rewiring the brain so that the visual information from the eyes is sent to the auditory cortex instead of the visual cortex. This kind of sensory substitution is a topic of ongoing research and has the potential to help people with sensory impairments experience the world in new ways. We would need to find a way to translate light waves into electrical signals that the auditory cortex, the part of the brain responsible for hearing, could understand. This could involve using advanced technology like brain-computer interfaces or neural implants to create new pathways in the brain. While this is still a theoretical concept, it opens up exciting possibilities for the future of sensory perception and human experience. Technology might be the key to hearing colors. Scientists are developing devices that can translate visual information into sound. Imagine a camera that could capture the colors of a sunset and turn them into a beautiful melody. Or a device that could help visually impaired people hear their surroundings. While still in early stages, these technologies show promise. They offer a glimpse into a future where our sensory experiences could be expanded beyond our natural limitations. Section 5. The Symphony of Everyday Life. In our daily lives, we often overlook the beauty and complexity that surrounds us. But what if we could experience the world in a completely new way? What if we could hear colors and see sounds? This concept might seem like something out of a science fiction novel, but it opens up a fascinating realm of possibilities. Hearing colors would transform our daily lives. Imagine walking down a busy street, and instead of just seeing the hustle and bustle, you could hear it in a symphony of colors. The red of a stop sign might sound like a sharp violin note, while the green of a traffic light could hum like a soothing cello. Everyday interactions would become a rich tapestry of sensory experiences. Imagine walking through a forest, the colors of the leaves and flowers creating a symphony of sound. Each shade of green, yellow, and red would contribute to a harmonious melody, making a simple walk in nature an immersive auditory experience. The rustling of leaves might be accompanied by a gentle flute, while the vibrant flowers could add a touch of piano keys to the mix. A bustling city would become a cacophony of color and noise. The bright lights of billboards and neon signs would create a dazzling display of sound, each color contributing a different note to the urban symphony. The honking of car horns and the chatter of pedestrians would blend with the visual melodies, creating a unique and dynamic soundscape. Each person's clothing would be like a unique musical instrument, adding to the urban orchestra. The vibrant hues of their outfits would produce different sounds, turning a simple walk down the street into a concert of colors. Fashion would not only be a visual statement, but also an auditory one, with each color and pattern contributing to the overall harmony. Food would have a new dimension, with each ingredient contributing its own visual melody to the meal. Imagine the sound of a ripe tomato, the crispness of a fresh lettuce leaf, or the richness of a perfectly cooked steak. Each element of the dish would add its own unique note to the culinary symphony, making dining a multi-sensory experience. The world would become a richer, more vibrant place. Our everyday experiences would be enhanced by this new way of perceiving the world, making life more colorful and harmonious. The symphony of everyday life would be a beautiful blend of sights and sounds, creating a more immersive and engaging experience for all. However, this new sense could also be overwhelming. The constant bombardment of sound from colors might be difficult to process. Imagine trying to concentrate in a brightly colored room, with each hue competing for your auditory attention. Silence, as we know it, would cease to exist. We would need to develop new strategies for filtering out sensory information and finding moments of peace in this noisy new world. If humans could hear colors, our brains would adapt. We might develop new ways of thinking and communicating. Language might evolve to incorporate new words for color sounds. Music would take on new forms, with composers exploring the interplay between color and sound. Our understanding of art, nature, and even ourselves would be forever changed by this new sensory experience. Art would be revolutionized if we could hear colors. Paintings would become immersive sonic experiences, each brushstroke a note in a visual symphony. Imagine experiencing Van Gogh's Starry Night with its swirling blues and yellows translated into a majestic, moving concerto. New forms of art, combining color and sound in innovative ways, would emerge, pushing the boundaries of creative expression. The idea of hearing colors might seem like science fiction, but it raises profound questions about our senses and how we perceive the world. It makes us wonder what other hidden sensory connections might exist within our brains, waiting to be unlocked. Perhaps one day the world will be alive with the music of color, a symphony of the senses beyond our wildest imagination.